Well, thanks for having us. I'm going to give a brief overview of the laboratory and what we do there and what I do as a chemist. And Kelly will talk about biology and DNA. So I guess I'll just get into it. Like you said, we service about 90 municipalities in St. Louis County, which includes about 60 police departments. All in total, it's about 2,000 officers we have to support as a county crime laboratory. And we recently moved into a new laboratory about 3 years ago, which almost quadrupled our size. In our old laboratory, we were literally on top of each other with chemists working next to biologists, and it was very cramped to say the least. So our new facility has been very nice to work in. We're an accredited laboratory. We've been accredited since 2005, which basically means we meet or exceed a bunch of standards that are set by an international organization. And we employ about 32 employees, from a laboratory commander to a quality manager. LIMS administrator is the person that maintains our case log database. And then we have various section supervisors, technical leaders, and analysts. So what we do in our laboratory, you can consider us a full service laboratory in that we have biology, DNA, chemistry, and firearms. Some of the more specific forensic disciplines we don't provide services for, such as gunshot residue, anything anthropology, trace fiber analysis, paint analysis, document analysis. Those things we all outsource through the Highway Patrol. We also have a digital forensics section, but they aren't accredited to our standards yet, but we're bringing them online, and their job entails extracting data files and media from any media storage device, from cell phones to tablets and computers are the main things people think of, but also car GPS systems or photocopiers. Anything that can store a digital media file, they can extract and put it into a usable form for an investigation. We work about 8,000 cases, give or take, a year. Roughly half of them are St. Louis County cases. The other half are from a municipal agency or a federal agency. This is some of our staff in administration and evidence reception. When we receive evidence, if it's wet evidence, we have drying cabinets now to dry them. Before, we used to have to use a glorified closet to try and dry out anything that was submitted wet. Contamination was an issue. Now we have nice drying cabinets where we can separate each item into its own drying cabinet. And our evidence vault, where we can store dry evidence and evidence requiring refrigeration or freezer storage. So now I'll get to some of the actual science. I'm a chemist. I do drug analysis as my main duties. We also have chemists that are trained in fire debris and explosives, but I'm not one of them, so you don't get to hear the fun stuff. But I'll try and talk about the drugs and the fire debris and explosives as best I can. So our lab analyzes a wide variety of drugs, the most common ones being marijuana, heroin, methamphetamine, and then the other ones kind of fall in line after that with crack cocaine, pharmaceuticals, and some of the more obscure, less common things like the quote-unquote ecstasy tablets or any of the spice, bath salt type compounds you may have heard in the media. We're capable of analyzing pretty much anything. Some of the common forms of drugs we'll see are tablets and capsules, vegetation, powders, crystals, and rock-like substances. And then we'll also receive liquids from meth labs, fire scenes. We'll also receive, we're starting to see more kind of soft putty-like materials being submitted. And then we also receive common paraphernalia, which we typically don't test. It's usually spoons, pipes, and syringes. Anything drug-related typically comes to us. The way we conduct our analysis is we kind of do a presumptive confirmatory type of scheme. So we characterize the sample using some general techniques, typically a color test, a chemical test, or chromatography, and then we move into a confirmation type test, which is instrumentation. So it's kind of hard to see, but this is an example of one of our color tests. But there are small samples of substance in this well plate, about the size of a pencil lead. Our tests are very sensitive. We require very little material. And then we look for color changes. So that's a common color test we do. This is another one. It's kind of hard to tell, but some of our color tests require multiple steps where we'll add multiple solutions together, look for a result, and then add something else and look for another result. So it's kind of hard to tell, but this is a biphase liquid here, and we're looking for this purple color to be leached into this bottom layer. And next to that is a negative control. So after we've characterized a sample, we'll move into a confirmatory technique using instrumentation. The two we use are mass spectroscopy and infrared spectroscopy. So this is one of our IRs. It's a FTIR, which is Fourier Transform Infrared Spectrometer. There'll be a quiz later. So what this guy does is basically we take a small amount of sample, place it right on this window here, smash it down with an anvil, and then we hit it with a laser. So we hit it with an infrared laser, and we're measuring how much of that laser light is being absorbed or transmitted at various wavelengths. And this provides structural data on the molecule we're analyzing. Based on how the atoms are bound together, the infrared energy will stretch or twist or vibrate those bonds, which give us structural information so that we can confirm what the sample is. This is a useful technique for determining salt forms and isomers because we're looking at how the atoms are interacting with each other. It's a quick test, only takes about a minute to run, which is nice, but it doesn't separate mixtures. So if I have a powder with 3 or 4 components, this won't give me a lot of useful data. Yeah, another good thing about this guy is it's non-destructive, so I can put my sample on it, measure it, and then I can take that sample off if I have a small amount that I'm trying to preserve. So this is what my data looks like. So basically, we're measuring how much light is absorbed and transmitted at each of these wavelengths. We measure in wave numbers, which is just the inverse of wavelengths. And then each data point is how much of that light energy is being absorbed or transmitted. And then the basis of forensic science is you take an unknown and you compare it to a known. So this top graph is my unknown, and this here is my certified standard that I'll compare to. And that's essentially how I make an identification using FTIR. The other workhorse of the lab is called a GC mass spec, gas chromatograph mass spectrometer. It's 2 instruments in one essentially. So what this instrument will do will separate out mixtures. I'll take a small amount of my sample and dissolve it into a solvent, and then we inject that solvent into an oven, which is this part right here. That oven vaporizes that sample and runs it through a long column, and it separates by lighter compounds move faster through the column, heavier ones take longer out to get through. And so I essentially measure how much time it takes to travel that distance. From there, the sample goes into the detector, the mass spectrometer, where that sample is then bombarded with a stream of electrons and broken apart into its pieces. And then I essentially measure how much those pieces weigh. So this is what this data looks like. Each peak representing a different compound coming off the instrument. And then when I click on those peaks, kind of hard to see, but I get all these other data points. And each of these data points represents a fragment of that molecule. And from here, I can build what the structure is. And then I compare it to my knowns. This is my unknown on the top and my known on the bottom. So we use that data to make our comparison and make our determinations. Let's see what I got next. Like I said before, we were in a cramped space literally on top of each other. These are some of the images of our brand new laboratory where we actually have room to move around without tripping over each other. One of our chemists working some, looks like marijuana. Because this oven gets so hot, it puts off a tremendous amount of heat. and the detector is under vacuum. So we have these vacuum pumps that are really loud. In our old lab, I literally sat with a vacuum pump in my ear and I could barely hear anything at the end of the day. With our new laboratory, we have our own instrument room where we're able to isolate these instruments and actually save my hearing. We also have separated Arson and Explosives into their own laboratory. Essentially, the analysis for Arson Explosives is the same as chemistry, where they'll do some characteristic tests and then confirm it using instrumentation. The arson analysis uses some solvents that are very hazardous, and in the old laboratory, we were never able to use those during regular duty hours because of so many personnel being around. Now that we have our own laboratory, we can isolate those samples and run them essentially 24/7, which has been nice. I'm going to also talk about our firearms section, since we don't have a firearms analyst that was able to make it here today. So our firearms section is a mix of commissioned and non-commissioned personnel, and their workload consists of examining firearms, ensuring that the firearms are functional firearms, comparing fired bullets and cartridge cases to each other to determine if they can determine which firearm they came from, if possible. They also do serial number restorations, distance determinations, and tool mark and shoe print impression comparisons. When they do a bullet comparison, what they do is they'll take the firearm and actually shoot it to retrieve the bullet in the cartridge case. And they do that by shooting it into a water tank. The water, being as dense it is, will stop a bullet within a few feet typically. So if you're ever watching those movies and they're shooting bullets into the water trying to get the bad guy, that's not real. I'm gonna burst that bubble now. Bullets only travel a few feet before they come to its rest in water. So they'll fire the weapon into a water tank, retrieve the bullets and cartridge cases from there, and then they'll compare them. We also have, if they don't need to compare the bullets or cartridges, we also have a firing range in our lab where they'll just shoot downrange just to make sure the weapon functions. But when they retrieve the bullets, they'll then take those two bullets, or the bullet from their unknown, and compare it to a bullet that they fired, and see if those two bullets were able to come from the same firearm. They'll do that by using a comparison microscope, where they'll literally put the two bullets side by side each other and try and line up the different striations that the firearm makes on the bullet as it exits the barrel. And they'll do the same thing with cartridge cases with the head stamps. What they can then do with those head stamps from the cartridge cases is put them into this National Integrated Ballistic Information Network. What this is a national database of images of cartridge case stamps from fired cartridge cases that then search on a national and local level to try and match other firearms evidence to a known weapon that may or may not have been seized. And we have our own microscope room for that the firearms examiners utilize. And again, we used to be literally on top of each other. Now they have their own laboratory. They even have their own bench spaces separate from their desks. They used to have to do everything in one location. Tool marks operate the same as cartridge and bullet comparisons. Anytime you use a tool, anytime there's metal on metal interaction, those two items are going to leave marks on each other. So when someone cuts wire, they can take the tool used to cut the wire, cut a reference wire, and then compare the two cut wires together and see if striations match up, and look for tool marks that are indicative and characteristic of that tool. Tire and shoe comparisons work the same way, where they'll take casts or images of footwear impressions and compare them to submitted shoes to see if they can identify through class and individual characteristics if they were made by the same shoe. And they'll take casts of items. If they find an impression in like clay or mud, they have different casting techniques where they'll pour a medium on there, let it harden, and then pull up that casting, bring in. And I'll let Kelly take over from here.
Hi, I'm Kelly. I'm in the biology section. In the DNA section, I'm a biology screener. Not actually a DNA analyst, but we'll try to get through that part. These are just some photos of our new lab space. The two on the one on the right and the one on the bottom are the DNA section. In biology, we do screening for body fluids, so anything that comes into the lab that needs to go to DNA, it has to go through screening first. So we look at everything, even if it may or may not have a biological fluid on it. It's then we sample it, we actually cut it, and it's transferred to the DNA unit. So there's several sources of biological evidence. It can come from blood, teeth, bones, hair, urine, and tissues. This is basically a picture of what we get a lot of times as a shirt. If there's a suspect in a shooting and they think there may be some blood on his shirt, a lot of times we'll analyze that for blood using our different techniques. For our blood, we do, these are all the tests that we do. Say it's a black shirt and we can't see anything, we always use luminol to try to identify the stain. So there's a picture of luminol in a bathroom. So that bathroom would have had no signs of blood, but then after spraying the luminol in the dark, it'll fluoresce like that and then it'll give us an area to test. The test that we use most often is phenolphthalein. It's a color change test. If we have a suspected stain, we usually always use phenolphthalein. It is a presumptive test, so there are false positives that come along with phenolphthalein, but it's a very quick and easy and inexpensive test for us to use. Typically, if we get a positive result, we'll always take a sample of that and we'll just forward it to DNA. The other tests that we can do are Takayama, and Takayama is a confirmation for blood, but it's not for human blood. So we'll take a sample of that presumptive blood and we'll put it on the slide and we'll drop the Takayama on the slide. When you look at it under the microscope, it makes these salmon-colored crystals. They're actually really pretty crystals. And then we usually will do a heme direct if there's enough sample left also. And the way the heme direct worked, it's a confirmation for blood, and it's also confirmation that it's human, upper primate, or ferret blood. So it kind of breaks it down a little bit more. We actually did have a sample once that was ferret blood, which was strange. But it works kind of like a pregnancy test. We put this sample in this little tube here. It actually stands up, but there's buffer in there. And we let it extract for about 10 minutes, and then we drop it onto this cartridge and wait until probably around 5 minutes until the fluid goes all the way across it, and it'll have two lines. If it's positive, there's a control line and then also your positive test line, so that you know that the test is working. So that's a good way to confirm that it's most likely human blood. We use the alternate light source to detect stains that could glow. We do a lot of samples. It could be any body fluid, but we use this also as a presumptive test on what we could potentially forward to DNA. We also test for saliva. We don't do this test very often, but it can be done. The way it works is it's a gel plate, and that gel plate has starch in it. And what we're looking for is amylase. So amylase is in saliva, and it's in really high concentrations in saliva. So if we have a sample that we think might contain saliva and that information would be beneficial, we'll extract that sample in just water, and we let it sit for a while, and then we'll take tiny little holes out of our gel, kind of like these right here. We'll take tiny holes out of the gel and we'll put that sample into those wells. It only takes like 4 milliliters, or microliters, sorry. It extracts in there, and then we turn the plate upside down. We put the lid on, turn it upside down, and then let it sit overnight. And the next day what we'll do is put iodine in it, and it will stain the plate. And the amylase actually will eat the starch away, and it'll give a big well. So you'll have a positive. So on this one, it looks like this was probably the positive control. So as long as the clearing is larger than your positive control, then you have a positive sample for presumptive amylase, which indicates saliva. Another thing we do is we look at hairs. We are not hair experts, but we can say that it's an apparent hair with an apparent root. And we have had cases, actually we had someone just testify recently on a hair case where they got a full profile off of a door frame in a home invasion. But yeah, so this is the possible root material, and then this one, it looks more like it's like a cut hair where there's probably no DNA evidence on that hair. So most of the cases that we get are touch and trace. So we get a lot of samples from door handles, cars, steering wheels, phones, and a lot of those samples are usually bad mixtures, but we can get a lot off of them. There's always a lot of DNA basically on every surface that you could find. So for the DNA unit, DNA is deoxyribonucleic acid. It's a blueprint for life. You get half of it from your mom and you get half of it from your dad. It varies from person to person. Unless you happen to have an identical twin, they will have the same DNA profile as you. The steps in DNA, the first step is the extraction step, and that just breaks the cells open and it gets the DNA out. After that, they do a quantitation step, and that gives them an idea on how much DNA you have in your sample. And then after that, they'll move it on to the amplification, where it makes millions of copies of that DNA, and then it'll go on to the CE, which is a capillary electrophoresis, and it will read that DNA for you. So then what it spits out for you is this electropherogram. And the way an electropherogram works is each of these little green blocks are a location, and then the number underneath there represents the number of the repeating locus on that location. So everybody has a unique DNA profile. This looks more like it's probably a known profile or a single source off of a piece of evidence, which is fairly rare. It's probably a known profile. So most of our cases will go into the DNA CODIS database. It's the Combined DNA Index System, and there's thousands of DNA profiles in that system. There's convicted offenders, there's crime scene samples, samples from missing people, and human remains. The database will, like, people from local and state databases can upload to this CODIS, so we can kind of compare samples to different labs that they may have uploaded also into the CODIS system. In 2015, we had 220 CODIS hits. In 2016, we had 356. So it's the more profiles that are getting put into CODIS is really benefiting how many people we can actually match up. That's all for DNA. We also have a photo service section, and they process all of the crime scene photos for us, and they print them out for the detectives and for court. Let's see, they photograph evidence. I don't think they photograph evidence too often, but they can photograph the evidence, and then they do film process as well as digital and make videotapes. They do all of our public relation photographs for the entire police department also. And then here's just some information on each of the jobs that are in the crime lab. Do you guys have any questions? Yes?
Because of shows like CSI and 12 or 15 offshoots of it. A lot of people have misconceptions about how all of this works. Like they get, a fingerprint hit the same episode, or they get a DNA hit like, 5 minutes. Can you go into a little bit about why that is very, very different from the real world?
Sure, yeah. So when we get, right now our backlog is probably at least a year if you have a burglary charge. We have a ton of cases and it takes a long time. So first it'll go to, in the biology DNA unit, it'll first come to us. We'll screen it, we'll send it to DNA, and just for them to even rush a case, say we get it in one day and we're going to rush it and we're going to do it as fast as we can, it's probably still going to be at least 3 to 4 days before someone can work it in biology, work it in DNA, and then have it tech reviewed and ready for the report to go out. Now chemistry is probably a little faster than the DNA process, and their backlog's not near as big either. But firearms also has a large backlog.
Chemistry process is a bit quicker. One of the things we have seen, particularly in court, and jurors are expecting evidence that might not exist. That's been one of the biggest problems the prosecuting attorney's office has encountered. So they'll have a case with evidence, but because it didn't go through the crime lab or it didn't have a DNA match, they're less likely to convict now because of those shows. And the absence of evidence is not the evidence of absence. This is kind of the common saying. And you mentioned fingerprints. One of the things with fingerprints that's not well known is they are fragile. It is really hard to get a good fingerprint that they can use. So those shows that they find fingerprints on everything and they know who it is in 3 seconds, it takes days and weeks to do that, and that's assuming you can even get a usable fingerprint.
Yes?
Do you guys ever know anything about the case or the suspects before you finish your testing, or do they keep that from you guys until you're done?
Well, in DNA, we kind of have to know a little bit about it because we have to know what we're looking for. So it depends on what the type of crime is. So if we know it's a sexual assault, we know what to look for. If we know it's a homicide, then we know what to look for. But we don't really know much about the suspects. There's a lot of demographics that we don't even have as a required field for them to submit evidence.
What kind of training and education?
I'm not entirely sure what the digital requirements are. Most of the requirements are a 4-year degree. In the crime lab, the general requirement is a science degree, preferably in biology or chemistry. For digital, any kind of a computer background with computer sciences.
Cisco certification.
I'm sorry?
Cisco certification.
I don't know if any of them have that or not. And I know some of them I don't think have a 4-year degree, so I know some of it can be replaced with specialized certificates.
Yes.
Do you all do your own blood analysis, like alcohol, drug content, that sort of thing, or do you outsource that? Or?
We used to do blood alcohol in the lab. When we updated our accreditation to the latest standards, we didn't have enough samples to justify bringing that discipline on under our accreditation, so we now outsource blood alcohol to the Highway Patrol. We've never had a toxicology unit. That all went through our medical examiner's office. But I think we use the Highway Patrol now for that also.
In terms of drug cases, what is the most prevalent drug that you identify?
Marijuana is probably still number one in terms of quantity. Heroin is a close second right now. And then meth and various pharmaceuticals kind of bounce around at number 3.
Do you all work with universities in terms of providing internships with students that are possibly majoring in biology or criminal justice?
We've had 1 or 2, but it's not consistent. It has to go through our department to get approved. I know the St. Louis City Crime Lab has had programs in the past with students in college level. We've done it sparingly.
Does your lab do anything with blood spatter analysis, or do you outsource for that?
I tried bringing on blood spatter a number of years ago. Right now we outsource it to Kansas City typically. Challenges of bringing on a new discipline is you can't just go take a couple of classes and then write a report. You have to show your training, you have to show your competence. And when you're bringing it on with no one there to tutor you, starting it up can take some time. I tried doing it a few years ago and didn't get a lot of support. And our backlog at the time in chemistry was about 2,000 cases, so I didn't have the time for it either. And it just hasn't been revisited.
What kinds of training does that require?
The blood spatter? That is mainly on the job, lack of a better term, on the job training that you get through other experts. So there's week-long courses you can go on for like basic blood spatter and then advanced. And then from there you would mentor under a court-qualified expert, and they would give you competencies and proficiencies and test you. You'd have to pass those tests and then ultimately take an issued proficiency and a mock court on it to show that you're competent. And then from there you could start writing your reports.
Kind of back on the chemistry side, when you get something in the lab, is it pretty much confirmatory? Like you know what you're looking for?
Over the years, you develop an eye for what you might think it is, but ultimately we start with a presumptive test and then go to confirmation from there. So yes and no. There are samples that'll still surprise me here and there I'll get, where I'll have to do a little bit more testing and I'll run a couple of different confirmation tests. But for the most part, being in the Midwest, everyone else has already seen it for the most part, so we've got a pretty good idea of what's coming through.
You mean everyone else, like the coast?
The coast, most of our drugs come from Mexico. Being on I-44 here, we got a direct route to the southwest. So yes, so Mexico is where we get most of our heroin from, and meth.
When you compare a shell casing to the database to see the markings, like how large is that database?
That database, in terms of number of entries, I know it's in the tens of thousands. I don't know, it might be in the millions, I'm not sure, but I know when they get their match report back, they might have 200 potential matches to filter through. All the evidence is kept in is either returned to the submitting agency or it's transferred to our property control unit, and they hold it indefinitely until they're told they can destroy it.
So it's like carrying something like comes in, if you have a lead or something,
you develop an eye for what it is, especially with like marijuana, because it's very visual. The point to, I guess, confirming those, it's mainly for court proceedings. So we won't do a drug case until we've gotten confirmation from the prosecuting attorney's office that they're going to take it. Does that answer your question?
Who's that back there?
Can you explain what you mean by a presumptive test?
Presumptive test indicates it might be something but doesn't confirm it. So one of our presumptive tests for hydrochloric salts. And a lot of drugs that are consumed is a hydrochloric salt. So one of my color tests will tell me it's a hydrochloric salt. So it won't tell me what it is, but it tells me what salt form it's in. That'll help me determine what kind of solvent I might want to use when I extract it. We have another presumptive test that reacts with methylene dioxide groups, functional groups. The most common ecstasy ingredient has a methylene dioxide group on it. So if I have an illicit tablet and I use that and I get a nice bright green color, I know there's probably a methylene dioxide group on whatever this drug is. So it gives you information to kind of guide where you want to go in terms of extractions and what kind of instrumentation to use.
So that you guys like deal with or get tests on?
Like in charges or evidence type or?
Like robberies or stuff like that, like first degree.
Burglaries.
Aside from drug possession, she was asking what's the most common case we do. Drug cases might be about half of those 8,000 cases we work in a year. So aside from drug possession,
Definitely burglaries.
burglary,
Yeah, in the biology unit.
Where's the nearest lab of your competency in the state? Like, does Franklin County have one, or do you have to go to Columbia? Or?
our accreditation dictates that if we outsource anything, we have to use a laboratory of the same accreditation. For us, it's the Highway Patrol Lab in Jefferson City. There's also labs in St. Charles County, St. Louis City, and Illinois has one in Fairview Heights, I think. Fairview Heights. So there's also a lab in Fairview Heights. And the Highway Patrol operates a satellite lab in Park Hills, but they're not full service. I forget what all they offer.
Of those 8,000 drug cases, how many of them are marijuana cases?
In the past, 30 to 40% of them. That's changed a bit lately since marijuana is being a little bit less scrutinized and heroin's kind of taken the focus of drug investigations. So right now, heroin might be our number one. I haven't run numbers lately.
How does your backlogging prioritization system work? Like, do you like value murders over like burglaries when it comes to figuring out like which crime to investigate first?
Yeah, we always prioritize homicides and sexual assaults. So we'll always do those first. Burglaries kind of get the back. So if it's a home invasion, those will be prioritized. Anything that's a person's crime, that's a crime against a person, we prioritize those over property crimes.
So I was just a little fuzzy on your time frames for the DNA stuff, like the 5-step process versus
Yeah.
running something for CODIS, which I'm sure is a massive database. Can you speak to that? Like, time, like so many days, hours, whatever.
How long the process actually takes. So it kind of depends on if it's a rush case or not. If it's not a rush case, say it's just going to go through the whole system, we'll screen it. If it's a burglary, it could be a year after it happened. We'll screen it and then it'll go into the DNA backlog once it's been through biology. The process between that is probably a couple months before it would actually get worked in DNA. And then it takes about a week for it to go through the extraction AMP all the way to the CE. So then they get the data off, someone else writes it. So it could be a week before it gets written, and then it could be a week before it gets tech reviewed. So, but that's the most streamlined process that we can do that gives us the ability to get the most cases out at a time, because we'll run 24 to 40 samples on one run. So those will all get worked together even though they're not the same case, and then they'll all come off at the same time. Does that answer your question?
I think so. How long would you get one of the samples that's completed the steps, how long does it take to run through that CODIS database?
Oh, the CODIS database gets ran, I think, every night now. They used to do it twice a week, and now I think Alan runs it every night on the nights that he's there.
Run it overnight and get the results.
Yeah, so if a sample was put in today and it would hit tonight, and then she would have the email tomorrow saying that hit notification.
Can you use the microphone?
Yeah, sure, sorry.
The CODIS system, it only tracks data from convicted felons or convicted assailants, right? People that are tested and proven not to be a match, that data is not kept.
Right. If you're a victim of a crime, but say we need your standard because they swabbed your doorknob because someone broke into your house, we'd need your DNA standard for comparisons, but we're not going to put you in CODIS. We'll only put in the unknown profile, or if we have a suspect buccal swab, we'll put them in as well.
How much of your job would you say is like doing the paperwork and filling out the proper documentation with the
About 80% for me. For every one day I spend prepping samples, I spend about 2 days doing paperwork for it.
Yeah, in DNA, it used to take a lot longer. In the biology section, we would handwrite all of our notes, and then we would have to go back to our desk and we would write a report. But we actually just implemented a new LIMS system January 1st. So now we actually have computers at our workstations, and we're typing in all of our notes as we go. And then when we're done, it auto-generates that report for you. So we don't even have to go back to our desk anymore to write a report. It's done. It's ready for tech review.
If in case you need to change them, does it have a member record where you change? Because usually that's a big concern. You change something and then you got deleted and you just put new information.
We have change management in place, yeah. So we have different techniques or different strategies for changing our worksheet should a correction need to be made. It kind of depends on what step of the process you're in and to how much work you have to do to document your change.
How is your evidence prioritized as far as what you work on? Like, does the Attorney General does the state have the ultimate say or something?
We take a lot of direction from our St. Louis County Prosecuting Attorney's Office. If we don't have some sort of prioritization for that particular case, it's first in, first out. If there's some sort of an ongoing drug investigation or something high profile, there's reasons that we'll work other things first and prioritize those cases.
Now, we also have a prioritization form that the officer would have to fill out, and he would have to get approval before we would work it ahead of any other cases.
How useful has your evidence been for like robberies? How often does that, end up being enough evidence to even help them convict someone?
It kind of depends on the sample. There's been times that someone's reached into someone's pocket and we'll get a profile off just swab in the pocket. It just kind of depends on what's submitted. I don't know the exact stats on per type of crime. More likely than a fingerprint, though. I'll tell you that.
I know you have a lot of protocols, but are there times where creativity comes into play with particular cases on what to do? We have to follow protocol, so we try and write our policies so we're not wedged into a corner on what we can and can't do. For me, being a chemist, I have a little bit of leeway when I try and, if I have a problem sample that I'm trying to extract, I have a little bit of leeway on what kind of extractions I can try. So you get a little creative in trying different solvents. This acid was too strong, I need a weaker acid. So if I wrote my policy saying I have to use sulfuric acid to acidify something, then I have to use sulfuric acid. If I say make it acidic, and I find sulfuric is too strong, I can back it off to something like hydrochloric acid, which is quite as strong. So we try and write our policy so we're not hemmed into a corner. So me being a chemist, I have a little more leeway with that. Can I answer the question? Is there a particular case or challenging case that you can kind of hang your hat on and say, man, I really did a good job on this one, break it or something? I've worked some cases where I had enough heroin on my desk to put out my house. So those are always interesting when you get involved in a big federal case. We participated in, I forget the name of the operation, where they raided 3 different places that were selling all the spice packets. So we went on a federal raid with them and they did that. So that was interesting. For a while there, I was a magnet for all the unusual drugs, so I spent several times where I spent the entire week doing nothing but one case. I've had a handful of those. We do, less often as a chemist. I only go maybe once or twice a year.
Yeah, I get a lot of subpoenas, but a lot of times we don't end up going. We'll go maybe 2 to 5 times a year probably. Sometimes they'll stipulate to your report, so you won't even have to show up. They'll just take what's in your report and trust the information.
How many cases include firearms?
25, you think? 25%?
Maybe. Maybe 25% of cases have firearms evidence. They seize a lot of guns. There's a lot of guns out there.
Could be more, I don't know.
Yeah, I'm trying to think about the number of we probably have 2,000 to 3,000 firearms just in our vaults right now, plus another 500 to 1,000 in property control waiting to come up. So we might have 3,000 or 4,000 guns just sitting around right now. And I know they've had cases where they've seized literally 150 guns.
In this area?
I was wondering, the airplane that had all the bricks of cocaine on it that landed at Lambert, would that be under your guys' jurisdiction? So is that a case that you're handling now?
Well, it depends on, the airport is in our jurisdiction. It depends on who's doing the investigation, who they want to use. If it's a federal investigation, maybe. It kind of depends on that case officer. Oxycodone, hydrocodone, and alprazolam. So Xanax, Percocet, and Vicodin.
What kind of career path would you take? Say you're doing your drug chemistry and you decide you want to do something else. I mean, it's like with most other jobs, you have a path you can take to get to somewhere else. Do you have other options at your work?
Depends on if you're qualified.
Bullets or whatever?
It depends on the education requirements and whether or not you have them. With our latest accreditation, they're getting a lot more specific over what coursework you have to be in a particular discipline. We do have 2 chemists that are trained as IBIS technicians, so they're able to take the fire cartridge cases that our firearms examiners generate, load them into that database, and then go through those hit reports for them. So there is some cross-training, but it's getting a little bit less frequent as accreditation standards get more stringent.
If someone has some drugs and they suspect it to be LSD, marijuana, PCP, or anything like that, how often is it found to be something other than what the employee suspected to be?
I'd say less than 5%. Is it something other than what the officer thinks it is? We do have cocaine and heroin. The white powders are the most common culprit there. 5 to 10, about 5% of our cases are truly the officer was completely off of what he thought this was.
Would you handle remember when anthrax was going through the mail or whatever, would you handle things like that where there was a substance in a package, or is that another group of people that does that?
If it's like a white powder that looks like a drug, the officer tends to submit it as a drug. We are not capable of identifying anthrax, so without some additional information, if they just submitted it white powder and I have no other information, it would go out as nothing detected, nothing identified, and it would end there. But without more information saying this might not be a drug, it might be a poison, or it could be an explosives component. It gets a different analysis. We could do it if it's an explosives component, but if it's something like a poison or some sort of biological weapon, that wouldn't be us. That wouldn't come through us.
Where would it go?
I don't know. I'd have to do some research on that. I don't even know if the Highway Patrol could take that. I'm not sure.
I assume you guys are always safe, because you never know what you're going to get. Goggles, masks, and gloves, and I mean, you have to. You try to protect yourself.
Right. We have as much or as little PPE available as you're comfortable with. So We've got gas masks issued, and we used to have full hazmat suits issued when we had more meth labs going around. But yeah,
There's biohazards too. You know,
right.
What you got.
The meth labs are going down.
They're less frequent than they were, say, 10 or 15 years ago. They still exist. They've kind of switched gears to a smaller scale, what they call a shake and bake method, making meth in like a water bottle, in a car, in a Walmart, wherever you can fit it. They still seize them, but and I don't know if it's a mix of enforcement commands or just less frequent, but they've shifted focus to heroin more than anything right now. So meth labs as a number has gone down. Whether or not they're still seizing as many is a different story.
In your opinion, what would be the top couple reasons that there is such a backlog of cases and thousands of cases? Is it lack of qualified scientists? I guess it's not lack of space. Is it volume? Is it dollars and cents?
It's more volume. The more stringent ICE or accreditation requirements get, the more you have to do on the back end per sample. So when I started, I could confirm a sample, I could confirm a drug with one sample, with assuming, and that was it. I could run it on the GC and call it what it was. With our latest accreditation requirements, I need at least 2 tests from 2 different categories on 2 different samples. So if I have a sample that I don't have a presumptive test for, I'm automatically making 2 samples for my instrumentation. So part of it's accreditation.
Yeah, also with DNA, the technology's gotten so much better that now we're doing trace samples. And so we're seeing a lot more cases submitted for DNA when they used to just submit ones that they think are blood. Now they're submitting so many trace samples from every burglary that we've just seen an explosion on how many cases are being submitted for the DNA unit. Yeah.
Do they take those cases back out of your backlog if they take it to court before they get the DNA evidence?
Yeah, we'll enter in a case, which is basically no report needed. The only thing other than that is we work all sexual assaults, no matter what. Even if the victim said that she lied or she made it up, we still work everything. Sexual assaults.
Are you also doing mitochondrial DNA?
No, we don't do that at our lab.
All right. Well, thank you very much for that really informative presentation.
Thank you.
Yeah.